Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The starting material is 2-methyl but 3N2-ol, i.e. CH3 to C, or CH is equal to CH2. It has a tertiary alcohol adjacent to a vinyl group. Moving on to the next step. Mechanism with HBr, allylic rearrangement via carbocation. When HBr reacts with an allylic alcohol, the OH is protonated first to give water as a leaving group. Loss of water generates a carbocation. The initial carbocation would form at C2, tertiary position, CH3 to C plus CH is equal to CH2. However, this carbocation is allylic and can be represented as a resonance hybrid with the positive charge delocalized CH3 to C plus CH is equal to CH2 dash, CH3 to C is equal to CH2 plus. Moving on to the next step. The two resonance contributors are tertiary allylic carbocation CH3 to C plus CH is equal to CH2. Primary allylic carbocation CH3 to C is equal to CH2 plus. And for the final step, bromide can attack at either end of the allylic system. Attack at the tertiary carbon gives CH3 to CBr CH is equal to CH2, option A, 3-bromo 3-methyl but 1Na. Attack at the primary, terminal, carbon gives CH3 to C is equal to CH to Br, option C, 1-bromo 3-methyl but 2Na. Although the tertiary carbocation end is more stable, Br, a good nucleophile under thermodynamic or SN1 conditions, preferentially attacks the less hindered primary carbon in an allylic system under typical conditions. More importantly, product C is the more stable product because it has a more substituted, trisubstituted, double bond. The double bond is between C2 and C3 in CH3 to C is equal to CH to Br, which is disubstituted trisubstituted, making it thermodynamically favored. The major product is thus the allylic rearrangement product CH3 to C is equal to CH to Br, which is option C. A would be the non-rearranged direct addition product at the tertiary carbon. It is the minor product due to steric hindrance at the tertiary center. B represents an elimination product with no bromine. HBr is an addition reagent, not an elimination reagent here. D retains the OH group. HBr replaces OH, so retention of OH is incorrect. Therefore, the correct answer is C. Therefore, the correct answer is option C.